Chapter 4, Loops Part 2. So it's a common error is to write an infinite loop by not updating the value of the loop control variable inside the loop. So recall that there are three parts to every loop. You have to initialize the loop control variable, you have to test the loop control variable, and you have to update the loop control variable. So in this code example here, while bow less than target, if bow is less than target, we enter the loop, year plus plus, interest equals bow times rate. Note that inside the loop we don't modify bow, which means that it will never be equal to or greater than target. It will always be less than target because we're not updating it inside the loop. So be on the lookout for infinite loops. Another common error is an off by one error. Now be careful here because some people say an off by one error is when your output is off by one. That is not accurate. An off by one error is when your loop executes one too many or one too few times. So you loop one too many or one too few times. That's an off by one error. If you look at these two examples, if we want to loop 5 times and we initialize our loop control variable at 0, we will loop while that loop control variable, finger, is less than 5. If we initialize that loop control variable at 1, we're going to loop while finger is less than or equal to 5. So notice the use of the less than versus the use of the less than or equal to. Be careful of that when you're writing loops. It's common to have an off by one error. So your book talks about hand tracing, and this is an important technique to be able to trace through your code and make sure that it does what you think it's doing. In this case, we write down the variable name, so n, sum, digit, and we just make column headings for them. And then we show what will be in each of these variables. N will be initialized to 1729, sum will be initialized to 0. Now the author of the textbook recommends using some kind of token, such as a paperclip, to keep track of where you are when you're tracing through your code. I prefer to just use my finger. Every time a variable changes, you need to write down the updated value in your little chart. So if we continue on here, you'll see that we enter the loop, n was 1729, so that was greater than 0. So we enter the loop and we calculate int digit equals n modulus 10. So modulus 10 will always return what's in the ones place, in this case 9. And then sum equals sum plus digit, so sum was 0, we add it to digit, which was 9, and we get a total of 9 and store that value back in sum. The next thing we're going to do is say n equals n divided by 10. That will chop off the ones place, and n will be equal to 172. Then we test. Is n greater than 0? It still is. Whoops, my slide updated an extra loop while I wasn't looking. So if n is 172, that's greater than 0. We enter the loop. Int digit equals n modulus 10. That peels off the ones place, which is 2. Then we add that. Sum equals sum plus digit. So 2 plus 9 is 11. We write that value down in sum. And then n equals n divided by 10, or 17. Next time through the loop, we're going to calculate, and 17 is still greater than 0, so we enter the loop. Int digit n modulus 10, that peels off the 7, digit now equals 7. Sum equals sum, which is 11, plus digit, which is 7, so 11 plus 7 is 18, and we're going to store that value in sum. And then n equals n divided by 10, so n will be equal to 1 after that next iteration. And there you can see that's validated. And then n, which is 1, is still greater than 0. So we enter the loop and we say int digit equals n modulus 10. It'll be 1. 1 modulus 10 is 1. And then we say sum equals sum plus digit. So 18 plus 1 is 19. And then n equals n divided by 10. 1 divided by 10 is 0. So our loop will be over. And we will output sum, which will be 17. Excuse me, 19. We will output sum, which will be 19. The for loop is very handy when you want to use a count-controlled loop. It's a loop that's controlled by, you want to loop a specific number of times. There are 3 parts to every loop: initializing the loop control variable, testing the loop control variable, and updating the loop control variable. If you look at this example of a while loop, we initialize where it says int I equals 5. Then we test while I is less than or equal to 10. We enter the loop, we modify sum, and then we update our loop control variable, I++. So those three things, initialize, test, and update. The super cool thing about a for loop is that it includes those three steps inside the for loop header. So for int I equals 5, semicolon, I less than or equal to 10, semicolon, I++. So the initialize, the test, and the update are divided by semicolons. Note that there is not a semicolon at the end of that line for int I equals 5, I less than or equal to 10, I++. There's no semicolon at the end. That would be logically incorrect. And then inside the loop, we're going to say sum equals sum plus I. So it does the same thing as the while loop. Both of these are two different ways to do the same thing. But a for loop is ideally suited when you want to loop a specific number of times. So here's the syntax of the for statement. For, initialize, semicolon, condition, that's your test, semicolon, update. And then inside braces, you've got your statements. If you don't have the braces, the for loop will execute only the next statement that follows, so only one statement that follows.